Okay. Hello, everyone. All right, everybody. Today's topic is about AWS Cloudformation plus Lambda for security purpose. My name is Chen, and obviously I'm from China, so I'm not a native speaker. So if you have anything not clear or you have got any questions during the time, feel free to interrupt me and ask me questions. I'm an information security engineer at Douala, specializing in application security. So I like crypto, logs, and kicking Benjamin's ass in ping pong on a regular basis. So this is the outline of today's presentation. We'll talk about background of this project. We'll talk about original workflow and its limitations. We'll talk about new design with example code walkthrough and lessons learned and opportunities. So a little bit background about what Douala is and what the project is mainly about. So Douala provides a payment API. So our main product is the API, but we do have a few web contents, including blogs, login and registration forms, dashboard with API integrations. We also have different environments for those web contents as well, including Devent, which is mainly used by our developers to do testing, UAT, which is mainly used by our customers to play with, and Prod, which is mainly used by our customers to move money. And original workflow limitations. We use a third-party tool to scan for web vulnerabilities weekly. But the thing is, we don't want to wait up to a week to detect new vulnerabilities. And we'd like to run scans as soon as code is changed. And we don't want the scans run on every commit. We only want it to run on for those with changes in front end. For example, if we make some changes at backend database, you probably don't want scan to be launched for like front end JavaScript or CSS files. And we want to integrate this tool into our CI/CD pipeline. So here are some tools or techniques we're going to talk about during the presentation. So I want makes a brief introduction about what these are. So Cloudformation enables the automation of resource creation and management. So for example, if you just need to define whatever AWS resource you need and write them down into a YAML or JSON file, and Cloudformation will provision those resources for you automatically. So if you change or delete those files, Cloudformation will also updates or delete those related resources for you as well. Lambda lets you run code without provisioning or manage servers. Serverless framework is a toolkit to let you configure your Lambda functions and the related AWS resources in a serverless.yum file. Jetstream is a tool used in Douala to manage Cloudformation stacks. So the reason why we use Jetstream instead of manage all the stacks separately is because we don't want to waste time to write the same Cloudformation stacks every time. We need some resource. For example, if we want to launch 10 different services, but they are all using AWS Linux server and with 4 gig RAM, for example, you probably don't want to configure them in 10 different repos. Instead, we want to centralize them into a tool, which is Jetstream. And Cloudformation custom resource, it lets you write custom provisioning logic in templates. So for example, if you have a DNS required for a project, but you're using Cloudflare to manage your DNS records instead of Route 53, how do you make that DNS record part of your whole stack? So Cloudformation custom resource would be the tool you want to use. So let's walk through the new design with some example code. So the first, you start from a Jetstream config file in project repo, and Cloudformation and Jetstream will generate a Cloudformation stack file for you automatically. And then in that Cloudformation stack file, you have the custom resource, which would point to the Lambda function. And Lambda function would call the third-party API to launch a scan, and logs would be stored in CloudWatch. So this is the start points. So if your developers feel like this repo is related to front-end stuff, and a scan might be needed for this repo. So all they need to do is to add this block of code to their projects. And JetStream will generate a related Cloudformation custom resource stack like this from here. And then in this custom resource stack, the type is custom. So Cloudformation will see, oh, it's a custom resource. And it will look for the service token, which is Lambda function ARN here. And it would call the related Lambda function to do whatever you want. So the Lambda function ARN is exported by the Lambda function Cloudformation stack. So, and then in that Lambda function in the serverless config file, you would see like functions main handler. It would look for this handler, and then always find this function. So all the attributes here would actually be passed to this events in a JSON format, so that you can do whatever you want. In this case, you just launch a scan to scan for your front end stuff, and the logs will be stored in CloudWatch. Then let's walk through like how to configure this and provision the Lambda function to do all of those. So you start from, this is going to talk about how we actually provision the Lambda function. You start from a serverless YAML file and a few like functions, and then you use serverless framework to provision it and generates a Cloudformation stack file. And Cloudformation will provision related resource. In this case, it will generate an AWS KMS key, which is used to encrypt and decrypt the third-party API key, so that it could hardcode those encrypted value into your config file. And it will generate a Lambda function, and it will export the Lambda function ARN so that it could be used by other Cloudformation stacks as well. And then Lambda function will actually call the third-party API to start a scan. And this is how it looks like to provision a Lambda function. And this is about the JetStream part, like how you actually configure JetStream to do all of those for you from the repo to actually call the Lambda function. So you got a JetStream config file, and JetStream will provision it and generates Lambda function Cloudformation stack file. And in that Cloudformation stack file, it has like import value. It will point to the Lambda function you created before using the function import value here, and then logs would be stored in CloudWatch. Lessons learned. Okay. I did learn a lot of things from while I was working on this. The first thing is Lambda function ARN could be exported via serverless framework using a default name of this. So you want export the Lambda function ARN because you want it to be used by other Cloudformation stacks as well. That's the purpose, right? So serverless framework generates the resource name, configure the resource name, default resource name for you, which is in this format. So it's pretty easy to just export it. And Python probably is not the best idea for me to write a Lambda function. So I do meet a lot of like unexpected issues. A good example is like I was using a library called a request, and it's going to make the API call to third-party API. And I was trying to print out the response from the library to CloudWatch, but it couldn't be recognized by the CloudWatch. So after spending a lot of time to troubleshooting this, I end up figuring out it's using single quote instead of like double quotes. So it's just a good-looking Python dictionary instead of a real JSON file. So Lambda Cloudformation customer resource and Lambda is great. So we could use this for a lot of security purpose. Like if you launch an EC2 instance, you want to do a scan to see if it has the opening port to the whole world, you could use this to do that. And if you want to run a Nessus scan to see if there are any like outdated libraries or like operating systems vulnerabilities, you could use the same way. It's just a very easy and nice way to a security check to your CI/CD pipeline. Lambda functions are super cheap, so we have hundreds of different Lambda functions there, and we probably run like hundreds of thousands times monthly, and the cost monthly is under $20, which is almost nothing. And serverless variable syntax are the same as AWS functions syntax. This one is pretty tricky. So, but you could actually change the variable syntax in serverless framework using a regex. What I mean here is like, so this one is actually a serverless variable syntax, and this is the AWS function syntax. So they're the same with the $sign and the bracket. But it's hard for serverless framework to tell which one is serverless variable syntax and which one is the AWS function syntax. And after doing some research, I figured out like you could add this and then you write a regex here to make serverless variable syntax to be double brackets instead of single brackets. That's a tricky way to figure this out. There are some opportunities here as well. Vulnerability detection and management may not be solved in a single Lambda function. So the current workflow for this is once the third party detect there is a vulnerability in your front end, it won't force the stack to roll back to the previous state. We do this mainly because instead it will notify like the security team, and we need to do some manual work to roll them back. We do this mainly because there are a lot of false positives. You don't want to keep rolling them back, and you don't want the scan will take an hour to be finished, so you don't want to stop everything for an hour. Lambda function waiting state. This is an interesting question. So the current workflow is you want to start a scan, and you want to check status. So if the scan is already running, you probably want to stop the scan and then start the scan. But the thing is, the process to stop a scan won't be finished very quick. It takes 20 to 40 seconds to finish this process. So you have to make your Lambda function sit there and just wait for it to be finished. It's not a good design because Lambda function should be designed to do something very quick instead of like just sitting there and wait. So a potential solution for this issue is we could use SQS and SNS so that we could forward the waiting time out of the Lambda function. The third opportunity would be Lambda function deployments require multiple provisionings. So this is an example config file. So you would see like we have the API key and secret key used by the third-party API. So this is the encrypted value. This original key is encrypted by the KMS key generated here. So, but before you provision this file, you won't even have that KMS key ready. So, how I did this is I provisioned this part first so that I could generate the KMS key, and then I use that KMS key to encrypt the API key and secret, and then I hard-coded the encrypted value here, and then provision it again, so that it would work for the. It would work. Yeah, that's pretty much about my presentation about all the techniques, the steps I was using. Any questions? Yes. Mm-hmm. So if I have a chance to redo the whole thing again, I'll probably choose Scala or Node.js because a lot of our developers use them. So I think there are definitely some benefits there. I know a lot of people using Python, but for me, for me personally, I don't think it's the best choice. Yes. Mm-hmm. Yes, we do have inspector enabled for all of our servers, but that's mainly due like to scan for like CIS benchmark, this kind of things. It won't scan for front end web vulnerabilities. Like if there is a cross-site scripting or cross-site request forgery, inspector won't be able to do that. So that's why we want add this into our CI/CD pipeline. Any other questions? All right, thanks.
Okay, we're going to take another break. Be back at 7 o'clock.